Hello students, let's continue the chapter Gravitation. Today we will derive the expression for acceleration due to gravity at a depth d, and we will understand the concept gravitational potential energy. Let's derive an expression for acceleration due to gravity at a depth d. For this, let us consider a body of mass m, small m, inside the earth of a mass capital M, and r be the radius at a depth d, as you can see in the diagram. So, the gravitational force between the earth and the body, we can write it as F is equal to G, capital G, m dash m by r minus d whole square. We consider this as equation 1, where this m dash, the capital M dash, is the mass of the inner portion of the earth of radius r minus d. So we have taken r minus d the whole square, and this g is the universal gravitational constant. Now weight of the body, we can write it as F is equal to mgd. Okay, where gd is the acceleration due to gravity at a depth d. We have taken it as gd. So we will consider this as equation 2. So from equation 1 and 2, we can write it as mgd is equal to g capital M dash m by r minus d the whole square. Both sides will cancel the small m. So what happened to the equation? Gd is equal to capital G m dash by r minus d whole square. We'll consider this as equation 3. Next, acceleration due to gravity on the surface of the earth, we can write it as small g is equal to capital G capital M by r square. We will consider this as equation 4. Now, dividing the equation 3 by 4, we get it as gd, small gd by small g is equal to, on the both side capital G get cancels. So what left? R square by r minus d whole square into capital M dash by capital M. So let us consider this equation as 5. Let rho be the density of the earth. Then the mass of the radius of r can be written as capital M is equal to 4 by 3 pi r cube rho. Rho is the density of the earth. So let us consider this equation as 6. Next, we will consider the inner portion of the earth of radius r minus d. So we can write the mass as m dash is equal to 4 by 3 pi r minus d whole cube into rho. We will consider this as equation 7. Now, dividing the equation 7 by 6, what happens? M dash by m is equal to, what all get cancels? 4 by 3 pi get cancels and rho also get cancels. What left? R minus d whole cube divided by r cube, which is the equation 8. We will consider this as equation 8. Now, substituting for m dash by m in equation 5. So we have m dash by m in equation 5. We'll substitute the value from equation 8. What happens? Gd, small gd, which is the acceleration due to gravity at the depth d, divided by small g, is equal to r square by r minus d whole square into, we will substitute the value of m dash by m by equation 8, that is r minus d whole cube divided by r cube. Next, what all get cancels? R minus d whole square get cancels and r square get cancels. So what left? R minus d by r. So we'll take the small g to this side. What happens to the equation? Gd is equal to small g into r minus d by r. Later we can write the equation as gd is equal to g in the bracket of 1 minus d by capital R. So this is the expression for acceleration due to gravity at the depth d, which is the below the surface of the earth. Let's define the gravitational potential energy. The gravitational potential energy of a particle at any point in the gravitational field of a body is defined as the work done in bringing the particle from infinity to that point. So this is nothing but the gravitational potential energy, the work done in bringing the particle from infinity to that point is called the gravitational potential energy. So in the next class, we will derive the expression for gravitational potential energy and we will understand the escape velocity. Thank you.